And things like Netflix making great series is because all of you guys are looking and watching specific series. So they know what you guys like. So what is a traditional infrastructure? Well, a traditional infrastructure normally kind of looks like this. We have some clients talking to an application or a front end that talks to a database or like a backend. And we can map this kind of infrastructure to a lot of applications. We can talk about a web browser talking to a web server that talks to a MySQL. But we can also talk about an email client that talks to an Exchange front-end server that talks to an Exchange backend server that saves your email. So this kind of application infrastructure we can map to most applications out there. Now, all of them use compute, storage, and memory. And these profiles that these applications, backend and front-end have, are different, but in general they all use compute, storage, and memory in a different way. Now, what would we do if we want to go from a traditional infrastructure and we want to bring it in the big data world? Well, traditionally we have to scale this thing up because, well, we were not having enough compute to be able to process all this data. So we're going to scale it. So what do we normally do? We buy bigger servers. We try to do load balancing. We do things like DB sharding, what I would never recommend doing, but it happens because it's one of the only ways. We try to split an application load. Like, for example, I could have a website that is running a website. The load becomes too much. So what we can do is we can say, okay, listen up. Website for Belgium now runs on one server. Website for Germany runs on another one. And if for some reason this would still be too much for Belgium, what probably realistically would not happen, but let's just imagine, we could say in Belgium they speak two languages. So we will have a Belgian-French server and a Belgian-Flemish server. And so on and so on. We try to chop this load up. This is what we do traditionally. What will we do with storage? Well, basically the same. We buy a bigger SAN. If what we have now doesn't fit, we'll just have to buy a bigger one. We can also split the load over multiple SANs. We'll be increasing the complexity, but we could, for example, say we have a DB server, and some DB files will be running on disks that are on one SAN, and some will be running on another SAN, and so splitting the load over two of them. We could also sometimes say, well, we need extra IOs, not storage. So what do? We buy a newer, more modern version of a SAN, with maybe flash as a cache, or let's say a full flash server, full flash SAN. We could also do things like server-side I/O caching. Put in some flashcards in the server, put some special magic software on there, and try to keep the IOs as close as possible to your servers to, well, mitigate that your SAN is not coping. But in the end, what are our cost and benefits if we're trying to scale up to what big data needs? Because we just increased the cost, we just bought all these new stuff. We increased complexity because, well, adding load balancers and DB sharding and I/O caches and more components, more possibilities to fail. And we are still limited, and this is very important, we are still limited to the per job performance of one server. We chopped up the load so that it fits on one server. But if I am asking you to do a query that needs performance more than one server, I am stuck. Those servers are not working together. I just chopped the load up so that it fits on a server. And well, not all applications you can scale that easily. A lot of times it's just very difficult. So, if you remind this statement in the beginning, what was our goal? Greater operational efficiency, cost reduction, and reduced risk. And I just upped the cost. I upped the complexity. With complexity comes again more cost. And I will have a very angry manager because everything I just promised, I just threw out the door. So this is not the way that you normally would try to bring a traditional system into the big data world. So, big data, like I said, there is not only Hadoop. I just said it to this person here when he asked the question. Hadoop is something that everybody kind of knows, and it's where I would say the buzzword big data started. But this is definitely not what big data is. There is not one product that fits all. That's the difficulty, but that's also the beauty of our job, because we are here to help you find that specific product. So for example, Hadoop, everybody knows it. But what really makes Hadoop so amazing is HDFS, the way how it writes all these things on the hard drives. But maybe not every use case likes this way of writing this data. Maybe there are other use cases where a different algorithm would be better to write this stuff. That's what these guys did. R basically made a system that writes this data totally different, more optimum for other use cases, but in the end speaks still HDFS. So all your applications that are running, that you can have talking to a normal Hadoop cluster, can also run on a R cluster. We can also have something that processes the data. One thing that is very famous at this moment is Spark. Spark is cool stuff. Spark enables you to do calculations of all these servers and make these queries that you usually were not able to do. And there are even things where we are talking about using Spark with CPUs and GPUs where the load gets split over those, depending on what you're actually asking for analytics. This is really the thing that, in my opinion, makes big data. The thing that processes all that data, that does something cool with it, that makes value out of this data. It's not an analysis software, it's a way of running analysis. So you can actually use this to do analysis, but you can also use it to just sort some data. You basically tell it what you want to do, and it can go from very simple to very complex. We have something like Elasticsearch. Like I said, not every use case is perfect for Hadoop. Let's just imagine that you have this system, your telco, and you have mass amounts of logs that come in, and you want to basically save it all and do analytics on it. For example, everybody knows here in Dubai, a lot of sites are blocked. If you want to help police search in this data that you all have to make sure there are no crazy ISIS guys hanging around, well, that's the system for it. You write all these logs in there, and with Elasticsearch, you can go and make all these analytics that you can actually go and predict what people are looking for. Now, of course, we want to also show something of this data, because let's be honest, not everybody is a developer. Like I said, I have no clue when these guys are writing SQL queries and what it all is. So I want to just see graphs. I just want to see only if I say, give me everybody that is looking for pizzas online, then I just want to have some visual representation of it. That's where Kibana comes in. Kibana is an easy dashboard that allows you to quickly go and look into your data with an SQL syntax and create nice graphs out of it. At home, for example, I use a competitor of it to monitor my environment, because I didn't like how the more normal monitoring applications were writing its data. I wanted to have every 10 seconds, not every minute or every 5 minutes. And as I said, big data is more than just Hadoop. We have Greenplum, for example, what is literally a database that scales out. But it's still a database. There's no HDFS going on there. It's just an SQL database. Let's just say that we want to have a database, but we want to run it on HDFS because, for example, we have some other applications that prefer talking HDFS. Then we can have Hawk. Hawk is an amazing tool that gives you a fully SQL-compliant interface on your HDFS. So you are able to run other applications that talk straight HDFS and use your application that talks SQL. Just link up that data, get it. And we can even look into the more other exotic databases. From the perspective of a DBA, these things are a bit weird because you're storing in data that has absolutely no relationship with something else, but NoDB is something that is hot. And you can have Cassandra, what is basically also a scale-out database. Or MongoDB, what is very popular. These are all examples of what could be big data. And believe me, there are hundreds more. And we as our team, we try to understand what are all the different use cases for all these ones. And we had in the past, I think, what was it, Mohammed? I think 2 meetups ago, we had SQL on Hadoop. Yeah? Where, how many did we talk about? About 6 or 7 different versions. And they all present SQL on Hadoop in a different way for a different use case. That is also the difficulty about big data. So what makes big data different from normal data? Well, first of all, everything is built for scale out. And all nodes work together. That is the huge difference between a normal infrastructure, where we just chop up loads and just try to get it to run on one server. Here, I can make a query that runs all my CPUs on all my nodes. And the chopping part is where Spark comes in. It will help me with Yarn, for example, to chop up these parts. I don't need to think about it. It will just handle it as one big application query that I'm doing. So let's just have an example. I can have HDFS saving the data on disk. I can have Spark processing the data. I can have Hawk presenting the data. And I can have Kibana that visualizes the data. And you can have this kind of stacks in different flavors. And in this way, I can easily just chop it into an existing application. Now, very important in this thing is that every component scales separately. So if I need more processing, I will just add more Spark nodes. If I need more disk space or more bandwidth to give me all these data sets, I will add more Hadoop nodes. So every component in your stack you can scale differently, and they are all scale out. So it's very easy to add nodes and also to take them away. So what is normally my life cycle in a big data infrastructure? Well, most people, and that's where most people are still, we're doing a lab. We want to run a lab, see what big data is. Then we will go to a proof of concept. We know what it is, we want to show our managers. We want to convince them, we want to show the value that this data would have in your company. And then of course, you run this thing in production. And this is where today we'll check into now, is we can have different infrastructures depending on where you are in this timeline. You don't need to buy immediately what you need to have in production if you're not there yet. So what I will be doing is I will be going over some examples of different kind of infrastructures that would fit depending on where you are in this timeline. So what are my goals when I'm doing a lab? Well, when am I doing a lab? I want to have low cost. Nobody has money anyway, so we have to do it low cost. I can't go and ask for 10,000 USD on my manager for a lab. He will not be very happy about it. So I also want to have an ease of setup. We all, as people, we all have way too many tasks to do. So I can't spend too much time on anything. And I want to be able to really easily scratch and rebuild this thing. I'm learning, it's a lab. I'm going to make mistakes. I maybe want to try and do something differently next time. So I want to be able to scratch this thing and rebuild very, very fast. And I have very low infrastructure requirements because, well, I don't have infrastructure yet. I didn't go to my manager. So what is an example of a tool that you can really use for this? It's called Vagrant. You can get it from Vagrant up. It works on Windows, Linux, and Mac. And what it basically does is it will take something called a Vagrant file. And a Vagrant file is a bit comparable to an index of a book. It will basically tell Vagrant what you want to have. So if I say I want to have a 3-node Hadoop cluster, in my Vagrant file it will say, give me 3 VMs with these specifications, install this software, and when you're done, give me these ports on this IP. And it's that simple. I gave you an example of a place that I like, this Pocket Cluster. It basically gives you a little website with a lot of big data applications. And as I said, there are so many big data applications, so don't expect them all to be here. But what actually happens is you just download a little file there, you do vagrant space, the name of the file, and you wait a little. And mostly after 5 to 10 minutes, depending on the speed of your internet connection, you will have that application, big data application running. So it's very easy to set up, very easy to start, and if you don't like it, you do vagrant destroy, and you start over again. So it is very easy to scratch and rebuild. If this application that you're looking for is not in this list, just Google it, just type in vagrant spice, the name of the application you're looking for, and you will probably find something. A lot of times, my colleagues and I, we have GitHub repositories with vagrant files in there for different applications, but also other people, they just write them. It's very easy to do. So vagrant, very nice tool. Another example, for example, could be the Hortonworks sandbox. You just go to the website of Hortonworks, and there is this little orange button that says Get Started. And basically what it is, it creates a Hadoop lab environment on some VMs. It works on VirtualBox and VMware. And they even have Hortonworks Sandbox in the cloud that gives you for 1 month free Hadoop in the cloud. So there is different ways to run this thing, so you have very low infrastructure requirements. Why?
These apps and these labs, are they only HDFS or we have other applications as well, like Live or other things?
So Hortonworks has already a very big ecosystem of Hadoop applications in there. So it's not only Hadoop HDFS. If you want to do Taz, Pig, or anything else, that's also already included. There's a lot included actually in Hortonworks. If you want to do it with Vagrant, well, basically Google is your friend. And you will find literally anything. I play with things like Kibana and Greylog that I use with Vagrant to quickly spin up to test something. But it can also just be, for example, Apache NiFi that is linked to big data, but is not really big data. Just a way of getting stuff transported. So Vagrant, I would say, is the more universal one, where you can literally go as crazy as you want. And Hortonworks is more Hadoop-based, but has such a big ecosystem that if you don't find it in here, well, you'll probably have a very exotic use case already. What I really like is we also have POC goals. Again, POC, we're a bit further, we know what it is, we have a little knowledge about what this big data stuff is. So what are our goals? We're still low cost. We're still proving to our management that we are going to gain value out of this big data stuff. We still really want to have something easy to install. I don't want to have 1 week of install time. And now, very important, what changed in our POC is now we want to simulate the production load, that if we would take this to production, we want to simulate what that would be. And we would like to extrapolate this load so that we can have kind of an idea of what we will need when we would run this thing on production. I don't want to go to my manager and just say like, give me a blank check and I don't know what it's going to cost. No, he's going to ask me, what is this thing going to cost? So I need to kind of tell him. And we also would like to test out, how is this thing going to work in our existing infrastructure? How does it link up with, for example, monitoring, or backup, or authentication? I can imagine that you don't want to just give everybody access to all your big data, like you just also don't give everybody access to all files on your file server. So you need to think about this, and this is the ideal moment to basically test this. So, as with the POC goals, now we have a bit more requirements. So we need to change the type of applications we have. And I'll show you a few examples. Again, there are many roads to Rome. There are only examples. There are others, but these are the ones that I like. One of them, VMware Big Data Extensions. It's a free tool. from VMware that runs on your existing VMware infrastructure, if you have one, of course. Otherwise, we'll go in a different use case. And it works with Big-Top Hadoop, Hortonworks, Pivotal, and Cloudera. Well, basically are the big four. There are some others, but if you don't want to do with any of these, then I would kind of think about maybe figuring out why you can't do it with these. And it helps you create all-in-one clusters, or even clusters that separate the storage and the compute. So it's very easy to set up. And thanks to VMware, we have a very easy way to collect metrics. Because while it's running on VMware, we can get the metrics from VMware. We can figure out exactly what this load is creating on VMware, and then extrapolate that if we would ever want to run this thing in production. So I'll show you a little video of how easy it is to create a big data cluster on VMware.
Welcome to our demonstration on how to deploy a Hadoop cluster with vSphere Big Data Extensions, also known as BDE. vSphere Big Data Extensions is available at no extra cost with vSphere Enterprise and Enterprise Plus licenses. One can deploy a Hadoop cluster with a few mouse clicks using vSphere BDE. In this demo, we will create a small Hadoop cluster using vSphere Big Data Extensions. Note that in this environment, Big Data Extensions has already been installed on the vCenter server. Begin by logging into the vCenter web client and go to Big Data Extensions. Select Big Data Clusters and click on the Add Cluster icon to create a new Hadoop cluster. Assign a name to the cluster and select the distribution type. Apache is chosen as the distribution for this cluster. Then choose the type of cluster for deployment. There are multiple options available. We choose the basic Hadoop cluster for this demonstration. You can customize the number of nodes in the node groups and their sizing. You can choose to have a small, medium, or large node group, or you can customize the node group for your environment. Each node group has multiple virtual machines, which play different Hadoop functional roles, such as data node and job tracker. We will select small configuration and customize the number of worker nodes to 2. We will also customize the storage size for this demo. There are also options available for the Hadoop topology and the network. We retain the default selection of host as rack that will treat the vSphere host as a rack from a Hadoop topology standpoint. This ensures that replica copies are stored in virtual machines on separate physical hosts. Then under Resources, select the resource pool to be used by this Hadoop cluster and click OK. The deployment of the new Hadoop cluster begins. Note that the deployment may take several minutes. Within the cluster, 5 virtual machines will be deployed, as specified in the Hadoop template. BDE provides the capability to add multiple Hadoop distributions from different vendors. Once the cluster is deployed, we can see that the 5 new virtual machines are running and are available for Hadoop computations.
Very easy to quickly set up these clusters. And the cool thing about it is, because it basically uses every single big Hadoop distribution, you can try out. Maybe you're a Cloudera fan, maybe you're a Hortonworks fan, maybe you want to go full open source. Choose whatever you want, deploy it, and well, you can reuse your existing infrastructure. So it's a cool tool to quickly get some of these things up. So another way, if we would go more in the direction of the open source way, we can also run Hadoop on Docker. Let's just imagine you don't have a VMware infrastructure in place, or you are using another tool, and you maybe just have some free servers lying around that you just quickly want to use. But I still want to quickly set up Hadoop and scratch and rebuild. So I'm going to look for another tool. Another tool that I really like is called Blue Data. So for example, Blue Data runs Hadoop on physical servers or VMs. So you can still also use it if you're using your VMware infrastructure. And it's amazing to run for POCs, or if you're a company that really needs very agile Hadoop clusters. Like for example, we can create all little data ponds for little Hadoop data clusters for different departments, and then aggregate it as one big to run our jobs on. And it's also very perfect for multi-tenant compute clusters. Like I said, we have maybe different departments and different in the same company that you want to allocate resources to. Maybe you want to give more resources to the financial department to do their analytics than you want to give to the HR department. I don't know. It's your decision. So this is actually a little movie also about what Blue Data does and how Blue Data gets you at the same endpoint, but in a different way.
The Blue Data Epic software platform eliminates deployment complexity by virtualizing your infrastructure using Docker containers. The platform has three key components. Elastic Plane enables multiple big data clusters in minutes. With data taps, you can start analysis without moving data. I/O Boost enables bare metal performance with the power of Docker containers and caching. Blue Data software simplifies and democratizes your on-premise big data infrastructure. You can consolidate your big data infrastructure and view usage by different business groups or tenants. Pool the compute and memory from a set of hosts, physical or virtual. Instead of rigid physical servers, lightweight Docker containers power your big data cluster nodes, so you are up and running at a fraction of the cost and time. Multi-tenancy is a first-class concept in Blue Data. You can create multiple tenants. You can configure granular resource quotas for each tenant, so they have dedicated resources to meet their service levels. You get ready to run images of the latest versions of Hadoop and Spark. Get going starting in minutes versus the many months it takes currently. You also get images of a diverse set of ISV partner application products that accelerates time to analytics. Your end users, whether they are data scientists or big data administrators, get self-service, secure access to big data infrastructure. The infrastructure team can enable self-service for their end users while maintaining security and control. Unique with Blue Data is the ability to create a logical data lake across multiple storage sources. Start your analysis without moving terabytes of data. You have the unique capability to let multiple big data clusters run jobs directly against NFS or HDFS storage systems without moving the data. You can create as many big data clusters as are permitted by your resource allocation. Blue Data promotes a big data DevOps model for multiple distributions and products. Creating a cluster is as simple as a few clicks versus thousands of clicks in a typical physical deployment. Scaling out is also just a click away. Unique with Blue Data is the ability to provision and configure BI or search applications automatically with your Hadoop cluster. Blue Data auto-creates and configures Hadoop and Spark clusters consisting of Docker container nodes, including management consoles. No special wizards and skills required. You get a ready-to-use environment with your favorite BI or search tool with Hadoop or Spark under the hood. Run big data jobs and workflows using your existing clusters or on-demand transient clusters. Simply point at your data and run analytics in place. Visit us at bluedata.com for more details and download the Epic Lite version for free.
Different way, without VMware, we are also able to very agile start deploying all these clusters, make temporary clusters, just to try out some jobs. You have immediately all the tools in there to start digging into your data and figuring out where is the value that I can give to my company. And on the other hand, I do want to point out that when you're going to use something like this and you're going to do analytics on something that is just an NFS share, don't expect the performance of a production system that is really based on Spark with HDFS. This is a really good tool to start digging in your data. You can run this thing in production, of course, also, but I would more studio it somewhere in, like, let's do a POC. Let's figure out what we are going to do. And then figuring out what your ideal infrastructure would be for your production. So what would our goals be in a production environment? Well, first of all, we want to make sure that it runs our production load. Otherwise, it would be kind of useless. Now, suddenly we have to think about growth. In a POC, you don't really think about that, but when you're doing production, you need to think about how am I going to scale this thing? How much data is extra going to come? How much calculations or analytics I'm going to do, so do I need extra compute nodes? Because I can tell you one thing, once big data has landed in your company and people start seeing the value, you have no clue how fast this thing can grow. Because suddenly everybody wants to do analytics. They will probably find some use case that they find cool about it. Then suddenly we need to integrate this thing in our infrastructure. Good thing we tested this out in our POC. We know now how we need to back up this thing, how we monitoring, how we do authentication on it. And now suddenly, this thing becomes an integral part of my company. We need to think about redundancy. Luckily, most of our big data applications have redundancy built in. So it's not that important that we need to do crazy infrastructures like we normally would do with more traditional applications. But big data has a lot of redundancy built in already, thanks to this scale-out technology. But still, we need to think about this. And now we also need to think about what is my cost of running this thing. Because just building something that is the Rolls Royce of big data clouds and running something on it, you need to think of what was my initial goal of big data? Cost reduction. We want to make sure that we do cost reduction. If we make this thing so expensive that all the great value that we get out of the data is, well, worth less money than what we're spending on it, then it's kind of useless. We need to think about multi-tenancy. Making sure that not everybody just has access to all data, and making sure that this integrates with your AD, for example. And of course, we want to see a result. You want to have those 3 items, the goal of big data, you want to have to complete. You want to go to your manager and say, yes, we succeeded. This is not a failed project that just spent money and is useless. So what are some of these examples of what we could use for it? Hortonworks. Like I said, there are different distributions. I just picked out Hortonworks now because it's one of my favorites. And why I like it? It's fully open source Hadoop. I'm a big fan of open source stuff. Don't need to explain you why, but for me this is a very important aspect. And I like it because it's an Ambari-based install. I'll show you quickly what Ambari is later. And for me as an enterprise, it's very important that this is an enterprise-ready Hadoop. This thing integrates with your existing system. This is an Hadoop version that you don't need to tinker in all different weird config files to get authentication running. They have in their install everything included. You want to get this thing running with Active Directory or Kerberos or what anything, that's in there. You want to have this thing monitored. You don't want your big data to just suddenly one day come up and say, well, we need extra resources, Mr. Manager, but I forgot to tell you because I wasn't monitoring my growth. Well, monitoring is included. Alerting is included. And it has a whole ecosystem of applications in there. I think at this moment there are about 20, 22 applications from the big data ecosystem that are all in there. I'm trying to think about it. I just installed one 2 days ago. But really a lot of use cases that you can already do are all included in there.
Applications. Basically, they are machines or systems.
So let me show you what Ambari is. So Ambari is a dashboard. And it's a cool dashboard in the sense that it helps you monitor your big data infrastructure. So you can kind of see how many name node operations are going on, and what is the load, and how many queries are going on. Well, it's all pretty cool. But here, you can see, for example, some of these applications that we're talking about. So standard, the most standard big data lake is having an HDFS. Basically saying, I can put data somewhere. Now I want to do something with this data, like I said with Spark. So for example, well, Spark is not in here, but I have Yarn. That is my framework that helps me run analytics on big data. I can have Test and Hive and Big and Scoop and so many others. And like I said, there is about 20 of them for all different use cases. If you want to run SQL on Hadoop, if you want to do analytics, if you want to do some visualization stuff. And if it's not included in Hortonworks, a lot of times you will see that a lot of these not included applications actually have a plugin for Ambari. So you can literally just pull in a plugin and then tell Ambari to install this. Because this is also the next function from Ambari. Ambari is your single pane that installs all this stuff. You need SSH access to your server. That's it. From there on, the moment you have SSH access to your server, you can just give it some servers, and you can say, install application Hive. It will give you in GUI some configuration files that you can change parameters if you want to, yes or no. You click install, you wait, and it's there. It's that simple. There is no going in CLI, installing stuff, and trying to keep versions of config files, because every config that you do through Ambari is in a sort of, let's say, versioning. So I can make a change in the config, apply it, and say, oh, this is not good. And I can revert it. I can literally say, go to version 1.1, and not version 1.2, because I did a mistake. And why I really like is that, as an infrastructure guy, one of the things that I get pretty happy about is graphics about my infrastructure. I want to see a healthy infrastructure. I love green lights, not red ones. Now, one of my biggest, I would say, biggest regrets about monitoring systems is that they mostly pull every minute, if you have a good one, but mostly every 5 minutes. And this is amazing because you get all average values. You get no spikes anymore. Everything gets averaged out. And a lot of times when you're doing debugging, you don't even know that something is wrong with your infrastructure because you didn't see it in your monitoring system because it was averages. Like, for example, latency spikes. You mostly see them on your SAN when it's already too late. So what is cool about it is that they integrated the thing that I also use at home, Grafana. Grafana is another tool for the same thing as Grafana. It's a visualization dashboard that you can also use to drill down in your data. But here, they use it to get metrics from your big data infrastructure. And the cool thing is they do it every 10 seconds. So you get metric points every 10 seconds. So you get amazing granularity from your data that is going on in your big data infrastructure. And the cool thing is you don't need to do anything for it. You just install the application, and it will take all the configuration from your Ambari install and generate these dashboards. So you don't need to tinker with it to get this out of the box. And for me as an infrastructure guy, this is where I get pretty happy about it. So let's see now, we talked about the software side. What are different tools to create an infrastructure? Now let's talk about what kind of hardware do we need? What infrastructure do we need to get these things going? So for our infra lab, we basically run our big data apps on a hypervisor, default virtual box. You can't do difference with Vagrant, for example. We have Vagrant orchestrating to deploy these things pretty fast, and we're basically running it on our laptop, Windows, Mac, or Linux. And we are using our storage, compute, and memory from my laptop. So unlimited, of course, to that, but for a lab, that's pretty good. So if I'm running this same thing now as a POC, luckily, I was able to procure a few servers, and I'm able to do a little VMware with VMware Big Data extensions, or maybe VMware, or not VMware, but I have some physical servers that I have lying around that can do some blue data, for example. And basically what now happens is, I replace my hypervisor from VirtualBox to VMware or to Docker. I have some more servers. I'm still using now more compute and memory that thanks to the scale out of my big data apps that I can all use together. So I can already put some more load on it. And I'm basically using a storage SAN that most of the companies already have lying around. Now, where are our limits here when we're doing this thing?
I had a question, Miguel. PNFI. See, while in our POC, we are using our laptop, or for the development environment, we are using our laptop. But as you are moving towards the production, so you are moving completely from a wired network to the optical network. Because in production, the boxes are in the optical fiber. Does that have any impact on performance?
We'll come there, and we'll still come there. But to be honest, going from a POC on a laptop to production, for me, from my perspective, is not a good idea. Because you are skipping some of the goals that you should normally test out in a POC. Like, how do you integrate this with your existing network? How are you going to, with so limited resources, try to figure out what your production load is going to be? You need something in between that, well, looks close to your production, but isn't your production, of course. But you need to be able to, well, get a feel of what production is going to be. When you're telling me I'm going to do a lab on it, or I'm going to do some development work on it, then yeah, sure. But otherwise, using that really as a POC for me is kind of dangerous. Because you will or overspend or underspend on your production infrastructure because you have absolutely no clue what it's going to be. But the rest of your question will come there.
So the question here, Pascal, how can you transition from a POC or a lab environment into production with the right sizing?
We'll come there. We'll come there. So let me quickly go back. So this is our infrastructure as a POC. Why is this POC and not production? Where are our limits? So we scaled out compute, and we added more servers. We scaled out memory, more servers, so we have more resources. We are able to scale our applications, our big data applications. We can scale out the data nodes, we can give it more processing nodes, we can have some visualization, we can all scale out everything. So let me ask you this question. Can we run big data in production, virtual on VMware or Docker or anything? What are your opinions? No, just speak up. And why? Why do you feel yes? So what would be the drawbacks of running it virtual?
Latency with communicating with actual hardware.
Yeah, a little bit. But is latency important in big data? Latency where? Where do you think latency is going to go up? Like between CPU and, yeah? Well, to be honest, with VMware and with Docker, the difference between a physical load and a virtual load is so small that personally you would not see up. But there is another place where you will have latency.
But Docker is not VMware, so it's completely different. It's pure VMware.
Yeah, but the technology that they use is totally different. So, not to go into the whole Docker stuff, but if you're using a hypervisor that is doing a one-on-one translation like what VMware does, or you're using Docker that more is an isolation of the software running on your hardware, you can't compare that. There is so little overhead in there. It's like if you're running Hadoop in Docker on a server, or you're doing it straight on the server, you will almost see no difference in performance. But there is actually a good question in here. So, big data, virtual, or on Docker. Should we do it in production? I would say, yes, you can. Should you? That's an option. If you feel like it, then you can do it. If you have like huge, massive servers, and your big data needs are actually smaller than what those servers are, then why not run it virtual? Get all the benefits of running something virtual, easy to provision, able to move VMs if it's needed. But at one moment you will see that the basic advantages are getting lost the bigger you go. So the bigger you go, at one moment you will say, maybe VMware is not so optimum anymore because I'm paying all these licenses and I'm not getting all the advantages anymore. But it's a question that you will figure out in a POC. When you have an environment that you can say, okay, I'm going to totally use this much infrastructure.
So to answer the question also, Pascal, it depends on your overall strategy for your environment.
Please take the mic, but at least everybody can hear it, because they are probably not hearing it.
So that will also depend on your overall strategy for your environment of your data center, right? Because big data or analytics is not going to be everything within your data center. You're still going to have traditional applications running there. You're still going to have some sort of DevOps environments over there. So the answer would be, it depends. From the get-go, I would say that, absolutely. From the get-go, I would say virtualization would be a good way to start everything, because you also, if you look at the bigger picture for overall environment for analytics of big data, you also need some sort of orchestration and automated provisioning. Cloud would be a huge plus there. So the general answer, it depends, but
It's like I said here, it's definitely possible. Do you have to? No, it's an option. And that is a decision that you need to make when you're making your big data strategy, like my colleague perfectly pointed out. Let me ask you the following question. Can I run big data on a SAN in production? Anybody?
Yes.
I hear some yes?
Yes.
Yes? Why?
You can. I'm not saying that you should, but you can.
Okay. For production. Anybody else? Some other opinions? No, not you.
I don't think so. I mean, it's not useful.
Why wouldn't it be useful?
And we are processing the
Okay,
data.
expensive cost-wise is one reason, but is there a technical limit to running big data on SAN? Tell me. No, just
Actually, the approach of having big data, the first place to have like scale out. So for example, instead of building bigger machines, you would have just more machines to do the job. So this is like in principle. SAN is in principle against that. So in SAN you would have bigger, faster machines, but does not have the scale out capability. So in general, what you end up with is basically you have complexity in infrastructure, and in terms of the management overhead and the capacity you're talking about, it's not a feasible solution. Technically, it could work, but is this the approach that companies should do?
well,
Absolutely not.
actually,
See, he added the point of infrastructure, but if you look at the processing part, the way big data processes, I mean, as this part
That's what I
of
wanna hear.
HDFS works, I mean, we do not require a huge data, it's just a chunk of data what we pick and we process it.
he is actually saying the thing why you should never, ever run big data in production on your SAN. Yes, there are reasons, like you said, management, cost. And I mean, SAN is pretty expensive for big data. It's like archive data. But there is actually another reason. There's a technical reason for it, why you should not do it. I'll try to explain quickly. So, if you have here a client that says, give me file A, that is in a Hadoop big data lake. He will basically say to all your data nodes that are storing this data, at the same time, and that is the important thing, at the same time, he will send a request to all these data nodes to say, give me a chunk of this file, because that's how Hadoop works. It basically took this file and spread it over all these data nodes. And now at exactly the same time, all these data nodes, all these data nodes go to the controls of your SAN. And most SANs have two controllers. Of course, there are some exceptions to it, like for example, an EMC VMAX. But then again, the whole cost factor comes in. Yeah, you're not going to just take a VMAX to run your big data on. And what basically happens is because they all request this data all at the same time, you get this mayhem. You get a huge traffic jam in your SAN. And I'll quickly explain you how this comes. So in my use case here, I had one client asking one file that was split in 8 chunks. And all these 8 chunks I'm going to ask to my SAN that has 2 controllers all at the same time. What basically means that in every cycle, I can process a little part of these chunks. So when I'm actually getting this file back is when I get all the chunks back. So I already have to wait for my SAN to process this. And this was one client asking one file. Just imagine that you're doing analytics on a 10 TB data set that is multiple files. And of course, now I don't have one client. I have a lot of compute nodes that are all trying to say, give me this data. Well, this is what happens to your SAN. And I can tell you, I have practical experience with this thing. trying to tune this thing so crazy to still get something to run on the sand, but it's really, don't do it. If you are doing very small little analytics, then yes, like I said, for a POC and even a little in production, you can do it, but you will very fast hit the limit of what your sand can cope with. And you can really throw some serious hardware at it and still fail. So don't run it on production until, well, like I said, POC or very small scale analytics you can still do. And one advice that I can give it, if you do have to run it on a SAN, forget the scale-out principle of Hadoop. Don't use 10 data nodes, because the more data nodes you add, the worse it becomes. The more parallel requests will come, and the worse your traffic jam will become. So try to keep it as small as possible. That is the only advice I can give you if you have to run it on a SAN.
So just to confuse people, like, but if you go for bigger data nodes, your VMware starts putting this job.
Yeah, there is always a drawback. Like my colleague already said, if you go for bigger data nodes, you will need more CPU, you will need more memory, and then of course, if you want to mix it with other VMs in your VMware infrastructure, you get the CPU queuing again. That one vCPU machines are going to fight with your 8 vCPU machines because you're all mixing them together. So there is always a drawback. That's why I said, in general, just don't do it. It's not a good idea. So what should you do? It's easy to say, don't do it. Maybe we should also tell you what you should do, or give you some examples of what you could do. Maybe it's better. So for example, we still have our big data apps, just like before. We have our servers that we still have, like in our POC, with a computer memory, and they're all running on our storage SAN. That's where we started out with our POC. Now, we throw in our hypervisor, that is optional, like we said. You can run VMware, or you don't. And we basically have our data nodes that are saving the data, running on direct attached storage. You can do VMware with pass-through just giving it disks, or you can just have servers with disks in there, or JBoss or something like that. Again, there are some best practices in there about how many CPUs with how many memory and how many disks. I'll come to that later. But in general, what you will get is that your analytics apps, or your visualization, or all these other apps, can be running, for example, in your existing VMware infrastructure, that is running on your SAN, so you don't really need to do much investment in new hardware. But when you're doing data nodes and you need to start scaling this thing out, one option could be servers with disks in them. Very cheap. And this is an example of how Yahoo runs a Hadoop cluster. As you can see, a lot of racks with all very cheap ass servers in there just to store the data. Nothing special. But there's a problem here. Because, well, let's be honest, not everybody is Yahoo or Google that has dedicated support teams to day and night just swap hard drives. There's a cool movie on YouTube that you should actually check out. And just type in, I think it's called Google Hadoop. And there's a video where you literally see guys in little segways drive to the data center with hard drives, because they are swapping drives all the time. And of course, in an enterprise that doesn't have the scale of a Google or Yahoo, this could potentially be a problem. That's why you normally have storage vendors like EMC. So how do existing storage vendors come into play? How are they trying to get into this whole big data stuff with infrastructure? Whatever you do, don't buy a SAN. I cannot repeat it enough. Don't buy a SAN for big data. It's not the solution. So what are some of these things that now are popping up everywhere? So we have a new thing now that's called big data appliances. And I'll give you some examples here. We have SBox, we have Amax, we have Oracle, we have Teradata that even has an appliance for Hadoop. And, well, to be honest, I don't really have much opinion about it. Everybody is free to do whatever they want. But this kind of says everything what you need to know about a big data appliance. This comes from Forbes, and this kind of also gets my feeling. A big data appliance is nothing more than an overpriced server sold by the traditional companies to mask that they have absolutely no answer to the big data trends and to try to keep them relevant in the new world. And it's really that. They are selling you an overpriced server. If you sit down for one day and you do a few best practice calculations, you will know how much memory, how much disk you need to put in a server. And that's basically what they are doing, and where they are charging a pretty nice surplus for it.
No offense to Oracle or Teradata.
No, definitely not. It's a way of doing a business, but it's trying to mask that, well, you had a product, it was good in the pre-big data world, and now suddenly the big data world arrived, and well, you try to push your product still, but you know that it's not working. So what do? You build an appliance and say, wait, we have an appliance for big data now, but it's basically just a server. So don't fall for it. If you want to go for it, just because of the sake of ease of management, one telephone number and stuff like that, then perfect, go for it. Because you know that you're paying this surplus for those reasons. But don't think that they are anything special. There is no magic in them. They're just servers where you run Hortonworks or Cloudera or anything else on it.
Question. With those appliances, on top of what you said, are there any, because some of them they offer the whole stack, including, you know, the big data applications or everything like that.
It's like I said, it's literally a server that takes Hortonworks or Cloudera or anything else and just tells you, here it is.
But would you lose some of the functionality if you go the other way around with, open source all the way? Like, are you restricted, for instance?
No, it's literally a server.
I know,
So
but
it's-
since the
you
support
can-
is coming from them and everything like that, they want you to sit in terms of what else can you put on that?
No, so it's pretty simple. If you go for a Hadoop distribution like Cloudera or Hortonworks, you pay for the support directly to them. If you go for a big data appliance, normally there are two ways. You can buy an appliance like the S-Max one that I showed you. That is basically, like I said, an overpriced server, and you install whatever you want on it. If you want to install Windows on it, you install Windows on it. It's a server. You also have other appliances, like Oracle, for example, that literally gives you a box and says, well, you can install Hortonworks on it and Cloudera by both certified Hadoop distributions. And you basically pay to Oracle for the support of the whole box, including the Hadoop that is in there. And they will figure it out with Hortonworks or Cloudera behind the scenes. It's a way of doing business. I have nothing against it. Just remember, the knowledge you can gain by just sitting down one day, you can design your own appliance, start up a company.
These appliances, they just run these tests on them, and then they say, oh, these tests work, so these servers work. So there you go, your appliance certified by Oracle. So that's my opinion, but that's exactly what it is. So some integration tests that run on this appliance with the same what you will install on any other server. And if all the tests pass, it's compliant. So there you go, you save tens of dollars.
And it's a bit, what they do is they take the knowledge, like I said, that is now in my head, that I also just gained of studying. And I will just say, okay, yeah, so my ideal data node setup would be 1.5 times disks per CPU core. And they just literally took all these rules and put it on an appliance. But if you would now say, well, I know, I have this knowledge, I know what to do, you can also go to Dell and just create a server yourself and say, this is my ideal data node. And my compute node maybe would be more CPUs and more memory and no disks. So this knowledge, they just translate it in. So if you have absolutely no knowledge and you want to go to an appliance, perfect. It's something for you. Now, as you know, we are at EMC, and we as EMC, we also have a way of doing big data. And it's actually a bit different than what normal people do. And normal people, other companies do. Let's say it that way. So it's something called EMC Iceland. And my colleague here that already took the front in it, he's actually one of the Iceland guys. So if you have any questions later on about this thing, he's the guy to talk to. So what makes Iceland so special? Well, Iceland talks HDFS. It's not an appliance where you install any Hadoop on. It's a box that has its own OS, that has its own functionality, but you talk to it with HDFS like you would talk like any other application. So you can take your Spark, you can take your other applications that all talk HDFS and immediately connect to an Iceland, like it would be a Pivotal or a Hortonworks or Cloudera big data lake. Very important, it integrates with all big data ecosystem applications. This is a compliant HDFS. There's nothing special on it, there's no thing that you need to think about. And very cool about this is you can start small and scale out when needed. So basically, 3 nodes is the minimum. Just like another big data Hadoop cluster. You need about 3 servers to be able to be redundant. So that is also the minimum here. It's a Hadoop in the box. Meaning, we don't have any extra services from Hadoop that needs to run outside of this box. We literally only have our applications during our computations that are external from the box. But all the data, all the other services that normally are in Hadoop, like if we go a bit deeper in there, like things like the name nodes and the data nodes, and all these services that normally run separately, they're all in this box. We don't need to think about it anymore. And it's very easy to migrate data to. And this is, for me, we didn't talk about this yet, but one of the key points why we as a team exist is because, let's be honest, installing Hadoop on a server, you don't need to call us for. It's pretty straightforward and it's not that magic anymore as it used to be. Why you call my team with my colleagues is because you say, well, we have 100 SQL servers and we will all want to put this data in my Hadoop data lake. So we would come up to you guys and we will help you build an application that takes all this data and pushes it in a specific way in Hadoop. Now, a lot of times, there are easier ways. And this is where Iceland really shines. Because this box talks SMB and NFS. I can literally take a file, CSV file or anything else, throw it on Iceland by NFS or SMB, and the moment it's there, I can query it with HDFS with my Kibana and visualize data on it. I just move the file very easily to it. I can even use this box as my file server and just say, well, my file's already there, I just activate my license and I run my analytics on it.
So I'll just to give an example here. So for example, in telcos, they archive CDRs, which are code records for a long time. And one of the benefits which companies can do is that you already need an archival platform for that, right? So this is something which you would need anyway. So the benefit of having Iceland is that you would be able to use Iceland as an archive platform for these CDR logs, and it's already HDFS. So for example, you can just have a couple of VMs deployed, maybe in a virtualized environment, and you already have a Hadoop cluster up and running, and you can start running analytics right away. So this is one of the benefits, is that you can build a data lake for many other use cases, and that data is readily available for Hadoop to be analyzed. So this is one of the key benefits here as well.
Yeah. For example, one of those use cases where Iceland really shines in the past, before the whole big data movement started, was archiving of video data. That was one of the first goals where Iceland was sold a lot, because it was very good in doing big streams. Now suddenly this whole big data stuff comes up, but our video is already on an Iceland, and now Iceland talks HDFS. I can now suddenly start doing analytics on it and do facial recognition. My data is already there, I already paid for it. So that's like one use case where you take an existing system with existing data that had nothing to do in a big data world, and now suddenly I start running analytics on it and finding value in data. I'll have a little video. Yeah, sure. Yeah.
Do people have some kind of operating system also in it? Because obviously on the top of server you require an operating system.
So in Iceland has its own operating system, and it uses something called OneFS. And OneFS is a nice marketing word, but it basically means that we have one OS that is one file system that is writing the data to the device, There's no rate magic going on in there. There's a specific algorithm in there called rate Solomon to write data way more efficient than you would be doing in a big data lake based on Hadoop, because Hadoop writes every data as stupid as possible, just 3 times at least. And what we basically do is we take different ways of accessing this data. So if you would see it in an open source way, you could say, for example, if you would take a Linux server and you would run, let's say, LVM on it, or something like that, to write your data, and now you would take Samba on it to talk with Windows servers, you put NFS on it to talk with NFS servers, we would take the whole data lake infrastructure, name nodes and all that stuff to talk with the NFS, with HDFS on it, but we now do it all in a way more efficient way. I'll let just somebody else talk about it, because I'm not an Iceland specialist.
Hello, I'm Asa Eisenhart, and this video provides a short overview of how a Hadoop data analytics platform and an EMC Isilon cluster work together. To begin, let's look at 3 important distinctions about Isilon and Hadoop. First, unlike traditional Apache Hadoop platforms, Isilon clusters serve as the storage system for Hadoop data, separating it from compute resources. In a traditional setup, storage and compute systems are shared resources. The Hadoop Distributed File System, or HDFS, is used for data storage, and MapReduce and Yarn are used for computational analytics. The name node is a separate server that holds metadata for every file that is stored on the data node. Each file is copied 3 times for protection. Often, production data is stored in production environments and then copied to a landing zone server to be loaded onto HDFS. This process is network intensive and exposes the name node as a potential single point of failure. On an Isilon cluster, each node acts as both the name node and data node, providing automated failover protection. Data is protected using a Reed-Solomon algorithm for data striping, which provides more storage efficiency. No data migration is required. The second distinction is that HDFS is supported as a native protocol in the Isilon OneFS operating system, the same way that other protocols, such as SMB and NFS, are supported. Here's how it generally works. After you activate an EMC Isilon HDFS license and accept the license agreement, OneFS turns on the HDFS service. Write data directly to the Isilon cluster using NFS, SMB, HTTP, or FTP as you typically would. Spin up a Hadoop compute environment and connect to any node in an Isilon cluster via the HDFS protocol to read and analyze data. Lastly, you can use Isilon's enterprise file system features for Hadoop data security and protection. For example, OneFS controls access to Hadoop data through directory services, such as Active Directory or Kerberos authentication. Permissions can also be associated with directories and files to control access at the file system level. You can also create virtual regions on your Isilon cluster for Hadoop data using access zones. The access zone encapsulates a namespace, HDFS directory, directory services, and authentication. System connections can be isolated per zone for additional security. Finally, data is protected by snapshots, replication, and NDMP backup. Now that you understand the basics, the next step is to determine which Hadoop distribution you'll use. Isilon supports Hadoop distributions such as Cloudera, Pivotal, and Hortonworks. The distributions are installed in a compute cluster, and then the compute clients connect to the Isilon cluster over the HDFS protocol to access Hadoop data. Refer to the Hadoop Starter Kit for instructions on how to implement your chosen Hadoop distribution. For more information about Hadoop and Isilon, such as best practices and implementation considerations, see the Hadoop Info Hub on the EMC Community Network. Thanks for watching.
If you're interested in knowing more about Iceland, we have here some great guys that can tell you probably way more than I can. But from the perspective of an architect, like I am, I will go in a little deeper why Iceland would be cool, or how it changes your architecture compared to open source. There are data nodes that we're running direct attached storage. So what happens now when you put in Isilon in this picture? that. So why is Iceland then very interesting when you want to go for a big data lake? Well, this, most of the time, we already have. We have that SAN, we have those servers, we have some virtualization going on. We only need to deploy these apps that you can do with Hortonworks with this Ambari install. And everything else is basically a black box. You don't need to think about deploying data nodes, thinking about how many data nodes do you need, how many drives in the data nodes do you need, and all these things, because Iceland takes care of that for you. And you can again have the advantages of having a storage vendor taking care of things like swapping drives, having a cold home if the drives fails, and all those stuff. So, how would you grow in a life cycle of big data, EMC style? I'm not going to start doing the dance, but let's go EMC style. So, like I said, we're doing our PRC, our laptops, best thing we can do. Have some Mac, have some memory, and start playing with it early as possible. Then we can have some servers with VMware on it, for example, and Hortonworks that is connected to some SAN. And basically on that SAN in our PLC, we're running our big data applications, and we are storing our data. And then when things grow bigger, we can still have those same servers, but now we take the data from it and we put the data on an isolate. And this is also one of these ways of how you can actually grow your data lake. Because at one moment, there is this, I think it's about 50 terabytes, something like that, on Iceland, that it's actually just cheaper to put your data on Iceland than just keep doing servers. Because your servers all have memory, CPU, have all these, these requirements about power. And, well, these things are connected internally with a very fast fabric. They have SSDs in there, they have drives in them. So they have like a more optimum way of writing the data. And with this Reed Solomon, you don't have the overhead that you normally have with a big data lake. Because writing your data 3 times, the bigger you go, the more costly it becomes. So that is always one thing that you need to keep in mind. So at one moment, at one point in time, it will just make more sense to go that way. And because Iceland integrates with your existing Hadoop, it basically means taking the box, installing it next to your existing infrastructure, and tell Hadoop to start migrating data from one to the other. This happens totally transparent, and once it's done, you point your apps to run on Iceland. So you have a very easy growth in there. So how would we do this in the more open source way? So in the more open source way, we again start with a laptop. We go to some servers that are running, for example, Hortonworks, with applications and data on local drives. And we don't have VMware in there, we're really going open source. The way how Hadoop was basically designed. This is how Google initially started doing their stuff. Having servers and servers and servers, no VMware in there, just plain servers, having a Hadoop installation on there, and having your applications and your data all on the same server. And then when things become more complex, this whole thought process of, is my infrastructure still cost effective, comes in. And then we start optimizing. We still have our servers, but now we have to scale those servers. And if it works, we now make separate compute nodes that are memory and CPU optimized, because that's what compute nodes need. They need to do all these calculations, and they need memory to cache the data that they're reading from your HDFS in memory, so that they don't have to wait to get it over network. And we have our storage nodes that are memory and storage optimized. So just think, for example, you could have little one-use servers that have a lot of CPU cores and a lot of memory for your computes. And you could have bigger 2-use servers that have maybe 8 to 12 hard disks per server that you can use for your data storage. And then again, you can scale them depending on your needs. You need more storage, you just add some more storage nodes. You need more compute, you add some servers. So this is a way how in an open source way, you can go from bigger and more complex. So, some best practices that I can give you. Always scale out, don't scale up. Can Hadoop work with servers that are bigger with more memory? Of course, it will use those resources. But Hadoop shines, and actually every big data application shines when you scale out. That's where it gets its performance. That's where it gets its redundancy. If you take a huge server and you have 3 and you lose 1, you're in big trouble. If you have 8 smaller ones and you lose 1, you will not even see it in your cluster. Buy what you need now. The whole point of big data and why big data is different than if you would normally go to a storage vendor is normally you go to a storage vendor, you say, I need a SAN. And you start calculating what your growth experience would be in 5 years. And you will say, okay, in 5 years I will be at that point, so I will need a model that fits there. And you will probably buy something that will fit you for the duration of 5 years. Don't do that in a big data world. Buy what you need now, add nodes while you grow. It's more cost effective, and you will get the last technology every time when you extend your data environment. And third time this meeting, don't run it on the sand. Whatever you do, don't make them run it on the sand. Then for your compute nodes, don't over-provision your memory and CPUs. Compute nodes basically try to keep data as much in memory as possible. If you're going to over-provision memory, it means that suddenly it's going to swap. And swapping will kill your performance on your compute nodes. And same for your CPUs. If they have to wait to do calculations, well, there goes your performance. And this is something that a lot of people forget. Even compute nodes need temporary disk space, overflow space, if they can't fit it in memory. Let's be honest, you have a data set of 10 terabytes, and you already have, let's say, 512 GB per compute node. Well, that's a lot of compute node if you want to keep everything in memory. So there is going to be some space that it's going to overflow. It's not that bad, but make sure it's fast disks. Something like a RAID 10 with some good drives, or sometimes just a RAID 1 with some SSDs. Could be an interesting thing to think about. And this is the last thing that I want to give with you. You need a fast network. When you're doing big data, you're going to basically move terabytes of data over your network between your compute nodes and your data storage nodes. And this means you need a fast network. To give you an example, if you have a hard drive, one hard drive does about 300 megabytes per second, times 8. That's already more than a GB connection. That fits, one drive just fits in a dual 1 GB link. So if you have a data node that has like 12 hard drives, how the hell are you going to do it with a GB network? It's just going to be waiting for it, or your drives are just will not be used. And also your compute nodes, they have to get in all this data to be able to do this compute, because you don't want your CPUs to wait. You just bought 12-core servers. Well, you don't want that money to go to waste. So you need a fast network. That's where your question comes in. So, is there a difference if you are doing? Is there a difference if you're doing it over copper or optical? No. Just like any other application, there is no difference. As long as it's 10 GB, it's 10 GB. If you can put it over there, it's fine. A lot of times what we do see is that 10 GB optical cards tend to have better chips and better drivers that are more optimum for doing stuff like that. But if you go with some good drives, with some good cards like from Intel or Broadcom, and you make sure that they can actually put through 10 GB, and not that there are 10 GB cards with a limited backhand, then you are fine. There will not be any difference. Only thing that I can give with me experience as an infrastructure architect, power consumption. If you're building a big data infrastructure and you have a lot of servers doing stuff over copper, for 10 GB will use more power than doing it over optical. And in the end, that will start costing you. And then a few of the last things is, let's look now some examples of what you could be using physically for starting to do this stuff. I left out the laptops. You will probably already have a laptop, so that part will leave. I'll give you an example of a simple Hadoop POC infrastructure. So what we have, a 3-node all-in-one cluster. Basically, data storage, application, all running on there. And of course, the more services you're going to add, like Hive and SQL, well, those resources are literally for like the minimum. There's not for like installing 20 apps. So I'll give you an example. Software we use, for example, VMware plus Hortonworks. And we use 3 servers with about a dual quad CPU. Why dual quad? Because we're doing application servers on the same boxes. About 64 GB per server is a nice way to start. And as you can see, storage, a 10 GB iSCSI or 8 GB per second fiber channel SAN for a POC should be enough. But it also means we need a network. And I would recommend you at least a 4 GB trunk or at least a 10 GB network per server, because you will need to get a bit of throughput. And why am I saying at least a 4 GB trunk? Well, you want to be able to use also everything from your data storage. Because your data servers are now virtual, for example, and they're talking to your SAN, that also means your network needs to be able to get that data. So what would be a an example of an open source infrastructure? So I know that some of you guys maybe are not so knowledgeable about Hadoop, what all the different components are. I would just say come back one of the other big data meetups or talk to some of my colleagues that can give you a crazy deep dive in what all these things do. But one of these things is the name nodes. Very important services. These are gone. That's the end of your data lake. So these two, for example, we're running Hortonworks, no VMware, we're doing really open source. And these, we need about 2 servers at least. You can even do 3, but let's go for 2. We're still doing it. And a single quad CPU should be more than enough. You don't need to have dual CPU because that is not so calculative intensive. But we do like to have some memory in there. For storage, we can go for like a RAID 1 local drive, and maybe a RAID 1 with some SSDs to keep the metadata on. To get as fast as possible this data so that we don't add latency to what already is going to happen with your data nodes. And as I said, about a 4 to 10 GB network, trunk or not, would be already nice. Then for our data nodes, again, we have, for example, Hortonworks. And this will, as it's for production, I cannot tell you how many servers you need. That is something that you will figure out in your POC. And so it's n times, for example, a dual quad CPU, 128 GB per server, because these data nodes, they like to cache also some data. And then, for example, a RAID 1 for your OS, and this is the most important part. Like I said, 12 direct attached disks or GBOB disks. No RAID. You don't need RAID. Don't make them tell you, oh, install RAID first and then throw in HDFS. It's useless. Let HDFS handle it. The HDFS will talk to all your drives separately and then scribe the data more efficiently. And here, it's pretty simple. You will need a dual 10 GB network. If you do 12 times 300, you will see that you will get at 8 GB. So if you want any redundancy, you need a dual 10 GB. Otherwise, it's useless.
That supports the InfiniBand.
Sorry?
InfiniBand.
That's the cool thing. This thing supports whatever you want. You can throw whatever you want to it, but if you want to go and do InfiniBand, it's going to be pretty expensive with your compute nodes. You need to also have that stuff. So I would just keep it network-wise. And then your compute nodes, again, how many servers? I don't know. But here, go with as much CPU as you can. Your first limitation in a compute node will be your CPU. That thing will be maxing out. And I say about 512 GB per server. You can add more CPU, more memory, excuse me. But what we see a lot is that the more memory you add, the more expensive your server becomes. And there is this point in time where it just makes more sense to add another server and don't add much memory. Because when you add a server, I have more CPUs, more processing power. And as this application scales out, that's it. So again, RAID 1 for my OS, and here I say about a RAID 5 for my temp disk. That's disk that actually gets my data when my memory is not enough. So something fast, or even a RAID 10. Actually, me personally, I prefer a RAID 10. And you can even think about doing some SSDs. One thing that you could do is sometimes mount this on another NFS share, stuff like that. It does work, but then you're throwing it also over your 10 GB network. So it's something you need to think about. And again, a dual 10 GB network. And as last, I want to show you how something so simple becomes when you throw in Iceland in it. Because, well, our name nodes and data nodes are in Iceland. We just need the license. And as an example, what would be a nice thing to go with is an X210 or an X410, like a 3-node minimum. And actually the difference in those is how many drives they have in it. So if you want to go with the philosophy of going really scale out, you take some smaller nodes and you take some more, or you take some bigger ones with bigger hard drives in it. And it all has to do with, are you going to be very calculation intensive, or are you going to be very big data set intensive? So mostly, me personally, I would always say scale out, then scale up. And that is a cool thing because you can mix and match. So you can actually start throwing in different nodes in there. And the only thing that we then need is these that are basically exactly the same as in our open source way.
What about the network on that?
Sorry?
What about the Iceland network?
So Iceland has multiple network cards per node. So don't worry about the 10 GB. Let's just say it this way. I probably see an Iceland kill your network switch faster than any traffic that you will be able to throw at it. So it has so much bandwidth. I think the minimum is what, 144 gigabits of bandwidth in total in the cluster?
Yeah, so basically like each, depending on the node type, so the X410 can give like over 1 gigabyte per second. So like each node can almost saturate a 10 gig link. Yeah. And each one of these nodes has 2 network interfaces, actually 4. 2 10 gig and 2 1 gig network interfaces. And so for example, if you have 5 nodes, you end up with 10 gig links. So from a networking perspective, the scale out and everything, not only the node type, because each node has all of the performance elements. So every single Iceland node has CPU, it has memory, it has network interfaces, and of course it has disks. So just an example, the X410 node, it has 2 8-core CPUs. So the node itself has 16 cores, just to deal with the storage part. So this part actually to relieve some of the CPU in the server itself, and also to take care of the data protection and everything else. So it will also relieve the load on the compute node. So you could even go with less specs on the compute part.